Hello everyone and welcome to my channel. Uh, Today's topic is Python coding in Datasphere. So those who are new to Datasphere, I will post a separate video for beginners. But today I'm going to cover only the Python coding inside Datasphere. It's something which everyone knows, but very less people use this. But before I begin, please subscribe to my channel so that you'll get all the latest video and please go through the entire video so that you will not miss any important points. Today I'm not going to show any presentation, I'm directly going to demo. So let's begin. Today the scenario that I'm going to cover through Python coding is that I'm going to create a data flow in Datasphere, which will use the Python scripting in between. And the data, the source data would be hierarchy with a parent and child relationship, and the target data will be level based data, which means that I will create for each child node. I'll create a uh, value across the column for all the levels. So I have done some level of development already before I've started this video. So what I'm going to do now is that I'll show you the data that I've uploaded already. So I'll go to data builder, and from the Datasphere home screen in the data builder, I have created the folder where I'm placing all my artifacts. Let's wait for a moment. Okay, so this is the folder within which I have created all the artifacts, and I will show you step by step what needs to be done. So it's opening. Give me a moment. Okay, so you see that there is a table that I've created, a local table called PNL hierarchy. But this is a dummy data. I made it as closer to reality as possible. So let me show you what data it contains. So it is created on top of the GL account. Now, if I go to see in the local table, I can view the data from here. So if I go to the data viewer and let me close the left panel. Okay, now let's see what data it contains. Okay, so as you can see, I have four columns here. One is child, one is parent, then child node description and parent node description. Now you can see that in the child, the first few set of data is for GL account. Now if I just scroll down a little bit at the end of GL accounts, I will see the nodes as well. So these are nothing but the level 1 parent node. As you can see, let's say for this example, PL0007 is nothing but the parent of this node. Now, if I want to go a further level up, I can use this parent as a child, and then I can find the further, the next level parent. The same goes on. So, for example, PL0005, I can pass in the child, and I can find what is the next level um, data looking like. Okay, so what we're going to do is with this data, I will create a table where you will see all the GL accounts, and I will have level 1, 2, 3, 4, 5. Let's say for 5 levels, I'll have the columns, and then I will populate them based, using the Python code. So how to do that? Okay, let me create a duplicate tab. Now before I begin, okay, uh, Python has a, it works with a library based manner. There are, a lot of libraries which you can import, and then there'll be inbuilt functions to it. But Datasphere has several restrictions. You cannot use, every feature of Python within Datasphere. So what you need to do is there are only two libraries that are inbuilt there. One is pandas and one is numpy. Today we are going to use pandas. Uh, Within pandas, there'll be a lot of functions that is that you can use. And one more thing that you need to remember is that within Datasphere, the Python coding works in a batched manner. Okay, that means you cannot, for large quantity of data, you cannot, let's say, delete duplicates. Yeah, because some of the duplicate values of the same key, can have, may have been included in a different package. So keep that in mind. Now let's start the actual demo. Okay, let me go to the data builder again, and let's create a data flow. Okay. I'm going to create within the same folder. Okay. Now within the same folder, let me create a new data flow. Okay, you can just click on new data flow, and this data flow that I'm going to create, that need to have a source. The source in this case is the you know table which is created. So that's PNL hierarchy, this table. So you just have to drag and drop this table here. Okay. Now let me close the navigation bar on this one as well. Okay. So now this is our source data. Now what I have to do is I have to use the script from here. Okay, let's drag a script. Now what I need to do next is I'll have to connect this to this, and then let me create a target table. So you can have an option to create a table automatically from here. That will be a target table. So by default, all the fields from the source is federated to the target. Now let's change that because this is not what we wanted. Okay. So in this table, first of all, let me change the name of the table. Let's name it as level based. Now what I need to do here is that let me remove all these first. Okay. So these are the things not report. And how to do that? You can go to the script, and here you can remove all these. Okay, and just delete them, and let's create the fields manually. Okay, so you can either add column, which will take the column from the source, or you can create new column. Let's create new columns here. Okay, so first column name is my GL account. Okay. GL account and string 10 is fine. Okay, now the next one that I need to create is the GL account description. So we just put as GL description, and let me put length as 100. So let's save it. Then the next one would be my levels. So I can just say as level 1, which is string 10. Then I'll have to create level 1 description. So level 1 description is again string 100. Same way, level 2, then level 2 description 100, level 3, then level 3 description, then I'll create level 4, okay, so level 4 description and length 100, and the last one would be level 5 and followed by level 5 description, and length will be 100. Okay, now I'm done with my structure of the field. Let's validate if it's there in the target structure. So as you can see, all these are federated here. Now, okay, let's create and deploy this table first. So as you can see, it is started and the deployment is in progress. Now, instead of having an append, what I'm gonna do is I'll do a truncate, which means it will delete the data every time before it is actually um, you know added with a new set of data. Okay. Now what I'm gonna do is the next part is writing the script. Now in the Python script, first of all, the version 3.9 is going to be out of support soon, so we will have to use 3.11, and then you can click on script. Now let's understand few things first. Okay, first of all, the script that you're going to write, there is no way you can compile the code to find out if you're writing right syntax or not. It will you will only come to know about this when you run the data flow. So then only in the log you will find whether your code is written correctly or not. So that is in a way a limitation, but there is a way you can do it differently. Uh, I will show that in a different video, but for now, let's focus on the coding part. There are a few things, right? First of all, data is what comes in from the source. So all your transformation logic has to be applied to the data. At the end, you can see return data, which means that it's expected that the data, is that needs to be changed, added with new set of columns or anything of that kind. You can do it, and then at the end, when you're returning data, the structure of this data must match with the structure of your target. So here, as you can see, the target are these fields. So if you're making change to the structure of the data, make sure that you are using the same fields in the same sequence. Otherwise, you'll end up with errors. That's number one. Second is that it is not mandatory that you will return only, you know, the structured data. You can, create other tables in the pandas terminology. We call it as a data frame. So you can, create other data frames within the code and then return that data frame as a target. And the logic remains same, that you need to use the same fields with the same sequence. If you think that your structure contains more field than the actual structure, then also it will end up with errors. So what you need to do now? Okay, let's break it down. First of all, from a logic standpoint, what you really need to do. So if I go back to the other table where I had the P&L hierarchy data in a parent-child relationship. Okay, I'm just opening that screen. So what will happen is, first of all, let's say if that table contains 100 entries, okay, your target cannot contain 100 entries. The reason because in the source that 100 entries includes not only GL accounts but also some of the second or third level nodes, okay, which ideally cannot be there in the level based hierarchy because they will be placed across the column. Now what you really need to do is, first of all, you need to copy all the GL accounts in the target structure. Okay, so if I show you the data again, okay, if I show you the data from this table again, so what you will see is, just give me a second. So what you'll see is all the GL accounts followed by all the hierarchy nodes. So you can see how you can take the GL accounts from here. The only thing that you can do based on this data is that all the GL accounts start with G. So anything that starts with G, you can filter that data, and you can only take that data and filter out anything which is not starting with G. Okay, that will give you only the GL accounts. That's the first step. Now, once that is done, and once you store the result temporarily in, let's say, in some other data frame, you can simply copy their first parent, which is your level 1 parent, in the level 1 data, because that is a very straightforward. Okay. Now, the tricky part comes with level 2, 3, 4, where you have to pass the parent node in a child node. Okay. So what you need to do is you need to loop on these table for each entry. You have to find the parent of that GL account, and you have to look up in the original table, passing the parent to the child and find out what are the parents. So once you do that, the parent node you can copy into level 2. The similar thing you can keep on doing, okay, for level 3, level 4, and level 5. In this way, all your columns will be filled. Now I'll show you step by step. Okay, let's go back to coding. Okay, so the first thing that you need to do, and that has to be there within line number 11 and line number 15. Anything beyond this is not permitted. Even if you're writing something, that will be ignored. Okay, so you have to understand this. Okay, second is, in this Python code, what is more important is the alignment of the code. In uh, things like SQL, or programming like ABAP or AMDP, any loop or any conditional statement, for example, if or if then else, this ends with either with an end if or with the end statement. Okay, using which system will understand that the conditional part has completed. Now we can begin with the next step of coding. So what will happen in Python? These, writing this conditional statement or loop, system will understand where it ends based on the alignment of the code. And I'll show you how it will look like. Okay. So to start with, what we need to do is we need to define the data frames. And as I keep on saying in pandas, data frame is nothing but a table. And you need to imagine that the data is stored in an array fashion, right? So that means the elements can be read from each of the row and column. And how you will do that? That also I'll show you. Okay. So let's start with the definition, and the comment you can just write using a hash sign. So for example, declaration is how we do it. Okay, let's start with one data frame. Let's say d1 is equals to, how you do it, you can use always pd is something which is defined automatically in other standalone Python code. You have to import the pandas as pd so that you can use that term pd always, okay, to call any functions. Now here you don't need to have that declaration. You can use PD directly as it is predefined by SAP within this code. Okay. So PD dot anything, any function that you are calling that has to start with PD. PD dot. Okay. So PD dot uh, data frame. So here you have to understand that it is case sensitive. Okay. So just write like this data frame, and under bracket, if you're just writing it like this, it means it will create a data frame, but the structure is still unknown. But if you're writing it as like this, then it will have a structure of the source data. Okay, so this data and this data is same, right? So that's number one. Now what I need to do is I need to define another data frame which I'll use as a return of the data. Okay, for example, here it is return data, so I will use let's say name as df. So df is pd dot data frame, and this will not have any structure. Okay, we will add structure based on the names. Now if I see the targets, okay, I'll have all these fields. So let's do a primary assignment. Now d1 already has the data of the source, okay, based on this declaration. So let's do initial assignment. So we say it as initial assignment, and we do field by field. Okay, so how we define, let's say we want to assign the the source has four fields, right? Child, parent, child node description, and parent node description. Okay, now what we are going to do is we will just say df gl account, which is the target, of course, is equal to d1 under bracket. This is third bracket we need to give when you refer to any column of the table. Okay, so d1 child, which means whatever value of d1 child is there will be copied into g1 account df account, and this will happen for each row. So the sequence is also important. Now dfgl account is this. Now let's repeat this for all first four. So gl underscore description is has to be copied from d1 child node description. Okay, let's verify whether this is the name. The source child node description. Fine. Okay, now same thing you have to do for the parent. So df level 1. So we can only assign level 1 at the moment. That has to be put under quotes. Single quotation equals to d1, then parent, and same thing for level 1 description. Level 1 description is equal to d1 parent node description. Okay, until this we are clear. Now same thing we need to do for the others, but we don't know what is the value of level 2 and others. Okay, so I'll assign as initial value blank. Okay, and df level 2 description here. Description is equal to this one, and let's copy this for all other. Okay, so level 2 is done. Level 3, level 4. I mean, I'll have to rename that. So level 2 is done. This is level 3. Level 3. Then this is level 4. And finally, this is level 5. Okay. Now the initial assignment is done. Okay. Now what remains is removing the nodes which is not a GL account. Okay. So we need to apply a filter. How we can apply a filter? So first we need to define the filter criteria. Let's do it as let's say df underscore filter. This is the name that I'm defining. Is a df GL account dot str dot starts with G. So this is defining. This is not yet applying on the table. This is only defining the filter criteria. Okay, and this means that it checks all the GL account which starts with G. Now let's apply the filter. How we can apply the filter? We can simply say df equals to df third bracket df underscore filter. As you can see here, this is df filter. So at the runtime, it will be replaced by the condition, and it will be, and the first df is the data frame on which it is getting applied. The df in the left side is the table which will be updated, and it will be overwritten. So all the values will be deleted, and this is the new assignment. There are other filter criteria like equals to or greater than or less than. All these things are possible. So now at this stage at line number 33, what we really have is the data filtered by all the GL account G, which means it will remove all the nodes. So we cannot check the intermediate data output. So what next that we need to do? So we need to run a loop on this data frame, and we need to find out what are the levels by passing it to the child value taking the parent. Okay, so let's start. uh, so normally for loop in uh, Python is based on the indexes or a particular variable. So I have taken index, and no, I can just say looping. See, this is only the comment, okay, on the data. So how the loop will look like? Okay, so for um, I in df dot index, and then all these kind of conditional statement or loop has to be ending by a colon sign. Okay, so you can see for I in df dot index. Now what it will essentially do is it will create a new column called index, the beginning of df for all the rows, and then it will check, okay, for all these indexes one by one. So it is advisable that you can reset the index at the beginning. So you can do that by df equals to df dot reset underscore index using this command. Okay, now if you press enter, you will see there's an indent that has happened, and if you try to write anything here, okay, that is not something which will be included within the loop. You have to mandatorily use the spacing here. Okay, a tab, not a single space. Okay, and the system will recognize that space automatically. Now what you really need to do, okay, So you really need to pass the filter into the original data from source every time the loop runs. So let's define a new data frame. Okay, and let's call it as data level 2, and let's not give any structure right now, just define an empty model. Okay, now what you need to do is here uh, uh, use that to store the lookup data. And how we can do that? So you already know that d1 is your source data from here, right? Now the filter has to be applied on d1. Okay, so what is the filter that you need to apply? So the parent from the loop has to be passed to the child of d1. So what you need to do is you need to write d1 dot child, and always in the filter section you have to use double equals to. Okay, is df level 1 dot values I, and I'll explain why I'm doing this. Okay, now let's break it down. Okay, d1 child, you can understand d1 child is nothing but the child data from the d1, okay, which is the source. Now you have to pass the level 1. See, level 1 is already assigned here for df for each row. Okay, so when for this loop runs for every row, df level 1 value is already defined. Now how to call that value? You cannot just say df level 1 because it will not have any reference to the actual cell. Okay, you have to point to the location for that particular loop run. The loop can run for 100 times. Okay, you just say df level 1, that will not bring the right data for that current loop index. Okay, so for that you have to use this syntax df level 1 dot values, and on the third bracket I. So I is a dynamic value which will change for every loop run. So when it runs for the first time, it will be value 0, which will take from the first row of the data. For the second loop run, the values 1 will take from the second row of the data. Okay, so this is a dynamic code. Now the outside d1 signifies that which table records that filter zone. So d1 records that filter zone. Now data l2 contains the lookup data where the child is the level 1 of that particular loop. Okay, now once you get it, now you have to assign this data into your level 2 and level 2 description. And how we can do it? Okay, so first let's understand one thing. Okay, if you want to uh, you know directly assign an element based on kind of this like values I, and if the main table does not contain any data, which can be the case not for level 1, for other levels, because it is not mandatory that each GL account will have 3 levels of data. Some may have only 1 level of data in the hierarchy. Some may have 2 or 3 parents. Some may have, even more. So when, let's say, you're trying to get this for the level 5, there could be many GL accounts where the level 5 does not exist. So your data L2, or the similar data for that level may not have any data at all because the lookup fails. There is no parent, of the parent of that gel account. Okay, so how, and this will fail your data flow execution. So what you need to do is you have to put a if condition here. Okay, and that if condition would be if length of, we call it alien, length of data L2 is greater than 0. Okay, that means this will run only if the lookup is successful. Okay, now you have to assign the level 2 and level 2 description. How we can do it? We will use the at function. Okay, so df.at, the bracket, I comma, first I'll write and then I'll explain. Okay, level 2 is equal to data underscore L2 parent dot values 0. So let's understand this. Okay, it says df at I level 2. This means it, how it is interpreted. Okay, for each, let's say when the loop is running for the first time. Okay, so this is nothing but this I will be replaced by 0, and this is nothing but the first row of data. So in the first row of data, the value of level 2 will be assigned to the parent value of the first row of data of data L2, which is this one. Now, surprisingly, data L2 cannot have more than one, record, more than one row. Okay, and which is why I've always given value 0, which means that the data frame data L2 will always have one row, and that is the single row's data I need to assign to the level 2 of the data flow, and of course the parent field. Okay, now is it clear? I'm trying to explain. If not, you can just go through this code again and again, and then you will understand why it is happening, and you'll have to practice it yourself. Okay, now let's do it for the same thing that I'll do is for the level 2 description. Same thing, exactly same, only the name of the field is different. So what is the name of the field? Level 2 DSC. Okay, so this is the, so now only thing you need to do is that here you need to change parent node description. Okay, now your level 2 is fine. What you need to do next? You need to do, see, you change the indent, which implies that your if and your for is completed. Okay, now what you need to do next is that you need to do the same thing for level 3. Now at this stage your level 2 and level 2 description is already assigned, so you can use it within the same loop run. Okay, so let's copy this code and let's make it as data L3, and here instead of level 1 you put it as level 2, which means that I'm reiterating that based on the next level. And this is just a copy paste. You have to do level 3 here. Instead of level 2 you have to do level 3 and level 3, and this is fine. You have to do level 3 here and level 3. Okay, this is fine. Now your level 3 is also done. So you have used level 2 to derive level 3. Now this data L3 has to be defined as well. So in the data declaration, just copy this and make it data L3. Okay, and let's define for all others as well, so that you don't have to come here again and again. Okay, after this L3 you have L4 and L5. Okay. Now let's go back to that code again. Okay, here let's do this for level 4, and so you have to use level 3 to derive level 4. Okay, we put level 4 here, level 4 is what we are trying to get it. Okay, level 4, right? Now let's do it for level 5, which is our last level. And here same thing, level 5, and here we pass it as level 4, here we pass it as 5, and assign 5. Okay, so now your all the 4 conditions are satisfied, but sorry, it's just a small mistake that I've done here, is that I don't need all these 4 loops, okay, because there is only one parent loop that is sufficient. I hope you got my point, right? So here what you see is the loop runs only once, and in that loop for each row, first you derive level 2, using that level 2 you derive level 3, using the level 3 you derive level 4, and using 4 you derive level 5. But you don't need a separate loop run for each one of them. It can happen simultaneously within the same loop. Okay, so now here your loop is completed. Okay. So as I said to you before, that when you use this kind of for loop, it creates a field, a specific field called index in the data frame. Now let's think about this, right? In the target structure, there is no index. There are 12 columns. But if you return df here, what will happen is there will be a mismatch in the structure, because your structure of the df contains that index field at the beginning. So you need to delete that field. How we can delete it? You have to delete it using this df, sorry, del space df, then in the third bracket you need to give the name of the field that you need to delete. Okay, then you can return df. Now it doesn't contain index, it contains all the 12 fields. So this is the end of that code. Okay, now let's recap what we have done. We have used d1 as a data frame of the incoming data, okay, and df as a target structure, or you can say target data frame. Now initial assignment is required because you need to remove all the data in the child node, which is not a GL account, which is a parent node, for example, of another parent. So first you have to assign the GL account directly from the child node. Assign the child node description to the GL description, level 1 as a parent, level 1 description as a parent node description, and all other field becomes blank. Okay, so this is the initial assignment. Now you have to apply filter. So the filter is based on where the GL account starts with G, and this is how you do it. You first construct the filter, store the condition in df underscore filter. Okay, the GL account dot str dot starts with G, and then apply that into the actual data frame. So now your df contains only the GL account, nothing else, and their parent values. Level 1 parent. Now looping on the data, first you need to, sorry, this is not rest, this is reset. Okay. Now this is where the index comes into picture. You have to use a for loop, and this is how you build the loop based on each index. Now data L2, L3, L4 and L5 are temporary data frames which will be used to store the lookup data from the source. And lookup data means that you have to pass the uh, parent from the parent is your level 1 from the target structure as a child in your source, and this lookup gives you the parent of the parent. Okay, so if you're using level 1 as your child, then what you get in the parent will be a level 2. Same thing for level 3. If you want to do it for level 4, then you have to pass the value of level 3 as a child to get the parent as level 4. Now data L2, L3, L4 and L5, they will contain the lookup value. And how you look up? You first construct the filter criteria, which is nothing but here df d1.child, which is a child node, equals to df level 1, which is the level 1 dot value I is the value of each row, okay, under that loop run, and then check whether the length is greater than 0, which means the lookup is successful. Then only assign the next level, okay, which is level 2, and this is the parent value of the lookup data dot values dot 0, which is the first row, and always there will be only one row of data, so it can for all the group run it can be hard coded to 0, and the same thing continue to happen for other levels. Now once this is fine, we have to delete that column called index and then return df. So this is the end of the code. Okay, now let's quickly see how the code is behaving. uh, let's name this data flow as uh, generate level based hierarchy. Okay, so there's no input parameter needed and everything is fine. Let's just go and deploy it. So we're asking to save. Let's save it. It will start the deployment process. The actual execution may take a little while. It's deploying now. So it's deployed. Now the next step would be to run this. Okay. Now we can run it from here. Let's say run and click on run, or you can go to data integration monitor. From there you can just do that job. Let's do it from here for the first time. And it may take a couple of minutes based on your system performance and the performance of the server. So you can click on this in the run status. You can see it is running. You can check the log using data flow monitor. You can just click here and that will open data integration monitor, and the data flow log will be automatically shown. Now if I started, you can see it is running a lot of things here. You can just refresh the screen. So sometimes it may take more time, but you have to be cautious. You can see the record count is not yet finished running, but you can see the record count in the source is 105, but in the target is 94. That's because we have filtered out all the parent nodes from the source while copying it to the target. And what 94 you can see are all GL accounts, nothing else. Let's refresh it once more. Okay, it's still running. That means the Python code, the loop is getting run right now. And as I say, it may take a little bit of time to complete. And then it also depends on the volume of the data, the type of coding you're writing in Python. So everything has to be taken into consideration. And still running. See, as it is running, let me tell you some other things. Sometimes you see that if you have done some mistake in the code and it fails, and you go there, change that code, and then deploy again and run again, you may get a locked issue sometimes. So if that happens, then you come here and then you can manually, you know, run this. You can just click on this and run it. If you see anything locked, you can just set as failed. If you see that the running status has not changed, you can set as failed. That will allow you to run it for the next time. Now, hopefully this is going to end. So direct run is completed. As you can see, the status is completed. Now let's go back and verify the data. So I can verify the data. You can just go to the target structure and you can tell you. Let's close this navigation bar and the details is also not required here. So what you need to do is you need to just click here and then there is something called display data, preview data. You just preview the data here. You can see the GL accounts are all populated here. And just scrolling down, you can see all these GL accounts are populated. And for each one of them, you see that the level 1, level 2 with description, level 3 with description, level 4 and level 5 if it is there, then all these things are uploaded correctly. Now I'm not going into data validation right now. The purpose is fulfilled. You're able to create a level based hierarchy, uh, and we can use it in a visualization tools like SSC to create advanced filtration criteria on your tables. And this is also something which I'll show you in my future video, that how to use this kind of hierarchical data to create advanced filtration in SSC using script. But today we learned how to use the Python script inside the data flow. The you know I've shown it for pandas, but I'll try to create some use cases for NumPy. That's the second library that can be used here. So that is concluding my demonstration today. If you like the video, then please like, share with your friends, your colleagues, and please subscribe to my channel. uh, I will post new videos every week. Sometimes it is getting delayed, but I'll try to post it every week. And there is in the description box. I'll try to paste this code so that you can try it on your own. And you know that would be all for today. Thank you for watching, and please stay tuned for my next video. Please subscribe to my channel and take care. Thank you very much for watching.